Hi, I'm Hannah with the Lake Superior National Estuarine Research Reserve, and I'm here to share a little bit with my colleagues from the Natural Resources Research Institute about our Science Collaborative project. We are working with many state, local, federal, and tribal agencies to create a collaborative monitoring strategy for a changing St. Louis River estuary. Here is Ewan describing the rationale and management need for this project.
The St. Louis River Estuary was established as an area of concern in 1987 by the US EPA because it had a lot of problems, including nutrient enrichment that had resulted in poor water quality in the system. Since that time, a number of best management practices and technologies such as sewage treatment have caused a noticeable decline in the amount of nutrient in the deeper waters of the system. So things have been getting better. We followed up these observations with a paleolimnology study to look at the history of the river based on fossil remains, and indeed showed that the deeper waters have been getting a fair bit better, but also that nearshore embayment type environments have evolving problems with increasing nutrients and increasing algal abundance. And this has raised some concerns, and that there have also been observations of harmful algal blooms in these embayment, more protected areas of the estuary, raising concerns that this is an increasing problem that is driven by contemporary issues that would not have been considered during the initial establishment of the AOC in 1987. Some of the driving changes may be climate change, increased precipitation, lower oxygen in the deeper waters that would feed excess nutrients to the system, things that we don't fully understand yet. And in order to manage these sorts of problems, we need to understand them first, hence the need for this study to understand the relationship between the algae in the system and the water condition.
Thanks, Ewan. And now here's Peter describing the when, where, and how we're conducting this research.
Sampling for our project on the St. Louis River Estuary began in fall 2022 and will continue through early 2024. In our sampling design, we sought to oversample with regard to parameters measured, number of sites, and sampling frequency. We routinely sample 8 sites throughout the estuary, which were selected with end-user input to maximize spatial heterogeneity. At these 8 sites, we collect a large suite of sensor measurements and discrete samples for analysis each time we visit, including parameters such as levels of nutrients, phytoplankton community metrics, water clarity, and more. In the winter, when the estuary is completely iced over, we sample the water under the ice at our sites every few weeks. In the spring and fall, we sample biweekly. From early July through mid-October, we sample at least weekly. Eventually, we will be able to perform a redundancy analysis on our dataset to whittle down our oversampling study design to a future monitoring program designed to detect and predict harmful algal blooms in a way that is both financially efficient to maintain and comprehensive enough to be effective.
The idea for this research was born out of a passionate group of caretakers of the river made up of Wisconsin and Minnesota and tribal agencies, natural resource staff, local and county staff, as well as other university researchers. Many of the details that Peter just described were decided on by this group, including the when, how, and how often we sample. We are engaging this group in person at 3 half-day sessions. Each session focuses on a key part of our research process or products. We are also actively participating with some of our end users in sample collection too, synergistically sampling together and matching sampling techniques. We are learning that one of the best ways to build strong connections is to get outside and do science together. Now, here is Chris to detail some of the final products of this project.
We will have several project deliverables that result from our research. The first are publications in the peer-reviewed literature examining the drivers of harmful algal blooms within the estuary. So identifying the factors that are contributing to an increase in harmful algal blooms and their toxicity is the first step towards building a monitoring strategy going forward, as well as any potential mitigation strategies. So all the data generated on this project will be put in an online repository that's freely accessible by the public. And that includes our statistical code that's used to generate any of the findings and analyses in this project. The biggest output from this project will be a recommendation report for what a future monitoring strategy looks like for the St. Louis River Estuary. This was the motivation for this work. All of our stakeholders see the importance of developing this strategy for a changing estuary, but no one really knows what that looks like. And so the data we're generating here will serve as the foundation for that recommendation going forward.
Thanks, Chris, and thank you all for your interest in our project.